Welcome back to our mathematics tutorials, which I continue with plane geometry. Our topic is on sector, segment, sector, and cone. Let us describe here a circle, and this circle has a center O. Now, from the center to any part of the circle is the radius. Let's represent it with R. Similarly, this is the radius. So let's say this point A and this is point B. So we now have a shape OAB. I want to now remove this as if I've cut it out. So I now have a shape here, which is part of the original circle that has the center O. This shape you see here is what we refer to as a sector of a circle. A sector of a circle. Center O. You now realize that a sector is bounded by two radii and an arc. The sector is bounded by two radii and then the arc. That describes a sector of a circle, center O. Now, let's go to the second diagram. We are looking at a similar thing to the first one. Here, this is the center, this is also the radius, this is the radius, this is the point A and point B. This is the arc. If I again decide to remove this, because I'm cutting that from the major circle, and then I draw a straight line, a curve, from A to B, and I have in this place a triangle OAB, and I also have a sector OAB. The sector includes this arc. The triangle does not include the arc. Now, this region that I'm going to shade off, bounded by the chord and then the arc, is called a segment. This is a segment. The region that is shaded. And this region is bounded by a chord AB and then arc AB. So we are now interested in looking at the area and the perimeter of a sector, and then of course the area of a segment. Let us now discuss the area of a sector. So we have area of a sector. Under the area of a sector, we realize that each sector has an angle at the center. Call it theta. Which means this arc here is subtending an angle theta at the center of the circle. Subtend means it's making an angle theta at the center of the circle. So in that wise, if we have to find the area of a sector, the area of a sector will be equal to, remember the area of a circle. The area of a circle is pi r squared. Then this is a fraction, a part of a circle. So that becomes the angle subtended all over 360 times pi r squared. This is the area of the sector OAB. So we now have that, therefore, the area of sector OAB is theta over 360 times pi r squared. Our pi usually will be given to us as either 22/7 or as 3.142, as the case may be. So that now is the area of the sector. Then now, what about the perimeter of this sector? So the perimeter of the sector, perimeter of sector OAB. Now, finding perimeter means that moving around the entire object. So, of course, this will be equal to moving from O to A, and moving from O to B, and then moving from B to A, or A to B. And our AB here is not a straight line, so let me write it. It's an arc. So it's moving from arc, from the point A to B, which is along the circumference of that circle, or the sector. Now, our OA is your radius. OB is your radius. Then our arc AB is the length of that arc. And how do you find the length? It's part of the circumference of that circle. So it will be theta over 360 times the formula for calculating the circumference of a circle is 2 pi radius. So this added together will give you the perimeter of the sector OAB. Now, taking a look at the segment, what do we need to know here? We want to do this. One, we want to be able to find the area of this segment. So we have area of the segment will be equal to, you now take the area of the entire sector. Remember that the sector is subtending an angle theta here. So the area of sector OAB, then minus the area of triangle OAB. Now, what is the area of the sector? We already got that as theta over 360 degrees times pi r squared. And what is the area of the triangle OAB? We use the formula which says half r squared, the sine of the angle at the center. Half r squared, the sine of the angle at the center, subtended at the center of that circle. So this formula will give us the area of the shaded portion called the segment in this case. Let us now look at a sector and a cone. We want to be able to draw out a relationship between a sector, which is a plane shape, and a cone, which is a solid shape. As far as this diagram is concerned, this is a sector, OASB. And this is the radius, OA, represented by L here, and this is the angle subtended at the center. It's like a shape like this, a sector. This is cut out of a complete circle. This is the center, the point A, point B. This is the sector of a circle, center O. It is a plane shape. You can see it flat. Now, from this sector, we have the cone. That actually this plane shape is equal to this solid shape, which is a cone, in this case, an open cone. And how is that one done? By folding this sector. Take a look at what I have formed. This is now the cone from the sector. So we have now formed a cone from the sector. You can see it. An open cone. See the open cone. It's not covered here. If you cover it, it becomes something else, which means it's a closed cone. But here is an open cone formed from the sector of a circle. From what we have seen in the relationship, we can now deduce the following. Let's start with the sector, as far as this case is concerned. Number one, the arc ASB arc ASB is equal to the angle subtended at the center all over 360 times 2 pi radius. And our radius here is represented by L. So instead of writing arrow, we will write L. Call this our first deduction. Then, what next? We discover again from here that when you folded the sector to form the cone, what then happened? You discover that the sector, the arc, is equivalent to the circle, the base of the cone. So we have that arc ASB is equal to the circular base. The circular base of the cone. Okay. Now, we have already seen that our arc ASB is equal to theta over 360 times 2 pi L. And then what is the circular base? The circumference of the base is 2 pi radius. That is the circumference of the base of the cone. Then what next? You discover that 2 pi, we cancel 2 pi. Therefore, our arrow is equal to theta L all over 360 degrees. This is your first major formula, how to find the radius of the base of the cone, giving a sector that has L as the radius and theta as the angle subtended at the center. Take note of this formula. Our third deduction is area of sector OASB is equal to the curved surface area of the cone. The area of the sector is theta all over 360 times pi arrow squared. This arrow is your L, because we have used L to represent the radius in this case. And we are saying it is equal to pi arrow L, which is the curved surface area of the cone. Recall that our arrow is theta L all over 360. Another deduction, the fourth one. From the cone, we have L there representing the slant height. And then we have H representing the height, or which I will refer to here as the vertical height. And then you have arrow, the radius of the base. Of cone. Alright. From Pythagoras' theorem, or rule, you have that your L squared is equal to A squared plus arrow squared. Let us indicate here angle alpha, the vertical angle. Our 2 alpha is the vertical angle of the cone. Take note that theta and 2 alpha are not equal. So now that we know 2 alpha is the vertical angle of the cone, we may be required to find the value of alpha, or the vertical angle, giving some informations. To do that, let us sketch the triangle, and here is O, and then here is the base. Let's call this point here point P, And then here, let's call this Q. This is the slant height, this is the vertical height, this is the radius, and this is angle alpha. For what we have, using trig ratios, from trig ratios, trig means the short form of trigonometry. From trig ratios, we have that sine of alpha is equal to R over L, opposite over hypotenuse. And of course, cos alpha is equal to adjacent over hypotenuse. And then we have tan alpha is equal to opposite all over adjacent. This is what normally results into use of the mnemonic called so, ka, toa. We have so, ka, and toa, representing a mnemonic for the trig ratios in a right angled triangle, such as this one we have just displayed. This one will enable you to calculate the value of the angle here. So when you multiply the value, alpha times 2 gives you the vertical angle. So we say alpha times 2 is equal to the vertical angle of the cone. These are the formulas we are going to be using in solving problems involving sector and a cone. Let us take the first example, example 1. Here is the diagram for you. And then of course you can see from this diagram that this is the radius, this is the center, this is the radius of the circle and also of the sector. This portion is shaded, this is the segment portion of this sector, and the angle subtended by the arc is 60 degrees at the center. So you are told to find the area of the shaded segment in the figure. And they are given options A, B, C, and D. Our solution. To find the area of the shaded segment, we will first of all find the area of the sector. So we have area of sector. In this case, the area of the sector is the angle subtended at the center all over 360 degrees times pi, and then times the radius, and radius here is 2, and it is squared. So eventually you will cancel this. This is 1 over 6, that is 4 over 6, that is 2 all over 3 of pi. Then you will now find the area of the triangle. So we have area of the triangle will be equal to half times 2 times 2, multiply this by sine 60 degrees. This simplifies to 2 times root 3 all over 2. Remember the special angles. The special angle sine 60 degrees is equal to root 3 all over 2. Now 2 we cancel 2, and that will give us root 3. Then the third step, say therefore, the area of the segment, area shaded, that is the segment now, will be equal to the area of the sector, which we calculated as 2 over 3 pi, minus the area of the triangle, which you calculated as root 3. So this gives you the solution to the problem. Let's say square units. Square units. This is the area that you are asked to calculate. Example number 2. The area of the curved surface of the cone generated by the sector of a circle radius 6 cm and arc length 22 cm is dash. We have the option A, 58 cm square, B, 132 centimeters square, C 66 centimeters square, D 77 centimeters square. Here is the solution to the problem. Let's sketch a sector. As you can see here, this is the radius and this is the length of arc. This sector was folded to form this cone, open cone. And then of course we have the slant height and we have the vertical height and the radius. Now we know that the area of the sector is equal to the area of the curved surface of the cone. Now how do I find the curved surface of a cone? So the curved surface of a cone is calculated using the formula pi arrow L. Already we know our L. We also know our theta. So this actually equal to, our pi, 22/7 times radius times 6. Our problem now is to find the value of R. And you can get that from knowing that the arc AB, which is 22 centimeters, is equal to the circumference of the base of the cone that has arrow as the radius. So we now say that 2 pi arrow is equal to 22. Now in this regard, our pi arrow is equal to 22 all over 2, and that is equal to 11. So in the sense of it, we simply have to substitute the value of 11 in pi arrow. So we have here now that our pi arrow L should be equal to our 11 times 6, and that will give you 66 centimeters square. So we no longer bother to find this one. You can find the arrow, put arrow here, the value of arrow there, and get what you need. Otherwise, you can simply have your pi arrow here to be 22/2, which is 11, and substitute and you get the solution. And the answer is 66 centimeters square. Example number 3. Two distinct sectors in the same circle subtend 100 degrees and 30 degrees respectively at the center of the circle. Their corresponding arcs are in the ratio A 1 to 100, B 3 to 1, C 5 to 2, and D 10 to 3. Our solution. Take note that they are talking about their corresponding arcs. So we take the length of arc of the first one, which has 100 degrees at the center. Length of arc will be equal to 100 degrees all over 360 times 2 pi radius. Then we take the length of arc of the second one. The length of arc will be equal to 30 degrees over 360 times 2 pi r. Now the ratio will be equal to 100 over 360 times 2 pi r into 30 over 360 times 2 pi r. 2 pi r and 2 pi r will go. So we now have here, this is 10 all over 36 into 3 all over 36. Now let's simplify this further. This will give you ratio 10 to 3, as 36 can divide 36 in both sides. 36 will cancel 36 if you carry out a division. And then you have ratio 10 to 3. And the option D is the correct one. Exercise number 1. A cone is formed by folding a sector of a circle having an angle of 210 degrees. Find the radius of the base of the cone if the diameter of the circle is 12 centimeters. Option A, 7 centimeters, B, 1.75 centimeters, C, 3.5 centimeters, and D, root 21 centimeters. Number 2, find the length of the arc of a sector of a circle, radius 6 centimeters, if the angle subtended at the center by the arc is 120 degrees. Option A, 4 per centimeters. Option B, 2 per centimeters. C, 1/3 per centimeters. D, 3 per centimeters. Number 3, an arc of a circle of radius 6 centimeters is 8 centimeters long. Find the area of the sector. A, 5/10 centimeters square. B, 24 centimeters square. C, 36 centimeters square. D, 48 centimeters square. Question number 4. A cone of slant height 30 centimeters has radius 5 centimeters. Find the vertical angle of the cone. A, 2 arc cos 5/13. B, 2 arc sin 5/13. C, 2 arc tan 5/13. D, 2 arc sec 5/13. If the radius of a sector of a circle is 5 centimeters and the length of arc of the circle is 12 centimeters, find the angle subtended by the arc at the center. A, 432 degrees. B, 432 per degrees. C, 432 all over per degrees. D, 216 per degrees. Here are the answers. Number 1, option C. Number 2, option A. Number 3, option B. Number 4, option B. Number 5, option C.